Box and whisker plot. A box and whisker plot, sometimes called a box plot, is a histogram-like method of displaying data. It was invented by J. Tukey in 1977. To create a box and whiskers plot, draw a box with ends at Q1, the first quartile, Q3, the third quartile. Then draw a third line through the median or the second quartile. Now extend the whiskers from the ends of the box to the maximum and minimum values. This, then, is our box and whisker plot. Each whisker and section of the box represent 25% of the data. From the minimum to the first quartile to median, median to third quartile, and third quartile to the maximum value for the data. Let's take a look at a box and whiskers plot. Here we have the first, second, and third quartile values for the response times for the Iowa EMS data. We also need to know the minimum and the maximum value, the smallest value 4.9, the largest value 19.7. These 5 values will be used then to construct the box and whiskers plot. Ends of the box are determined by the first quartile and the third quartile. The entire box then represents 50% of the values. It is called the interquartile range. From Q1 passing through the point of median to Q3, the third quartile, is 50% of the values. The median, or Q2, is 7.7 for this particular set of data, and it is the line that's drawn here in between the line or ends of our box that were determined by first quartile and third quartile. It splits the data in half. 50% of data is smaller than Q2 or the median, and 50% of the data is larger than the median or Q2. Since the lower quartile or Q1 splits the lower half of the data, the area from the smallest value, or the left end of the whisker, represents 25% of the data. And the area from the first quartile value to the median represents another 25% of the data. And you can see here from this example that they are not necessarily the same width. We'll talk more about that in a bit. Likewise, the upper quartile, or Q3, splits the upper half of the data. And the area from the median, or second quartile, to the third quartile represents 25% of the data values. The area from the third quartile to the largest maximum value, in other words, the end of the right whisker, represents another 25% of the data. And we can clearly see that this range is not the same size. Let's look at another example. Given the following scores on a math test, create a box plot. Our first step is to rank or order the data to determine the 5 summary values needed for the box and whiskers plot. So here's the data in numerical order from the smallest to the largest. Next, we need to determine the median or the second quartile value. There is an even number of data values here with 18 in total, so the median will fall between the 9th and 10th values. When there is an even number of data values, to determine the median, we will find the average of the numbers on either side of the middle. So adding 93 plus 94, dividing it by 2, results in a median value of 93.5. Next, we will determine the median of the lower half, which is our lower quartile value, which for this example is 88. We will determine the middle of the upper half of the data, which is 96. There should be equal numbers below that value and above that value, as well as the Q1 has the same result. The last two pieces of information that we need to establish for creating a box plot is the smallest and the largest value. With the data ranked, it's pretty easy to identify the smallest and the largest values. Now that we've identified those 5 summary values, we're ready to construct our box plot. The smallest value is where the graph will start the whisker unto the point of Q1. Q1 and Q3, the first and third quartiles, will determine the ends of our rectangle. The line drawn here is our median, and from the third quartile to the largest value, we extend the whisker. Recall, each whisker and section of the box represents 25% of the data. If the data was equally distributed, the whiskers and sections of the box should cover approximately the same range. And as you see here, that is not the case. The left whisker is substantially longer. This 25% range is much larger than any of the other 25%. We'll take a look in the next video on how to deal with this kind of situation.